Dr. Mark Ho, President of the Australian Nuclear Association. Thank you so much for joining me on the Titans Nuclear Podcast.
Thanks for inviting me.
So where are you right now?
So I'm actually in one of the conference rooms at ANSTO, which is the Australian Nuclear Science Technology Organisation. And yeah, so this is what you see in the background here is the picture of the Opal reactor. That's our 20 megawatt research reactor.
20 megawatt. That's 20 megawatt thermal?
That's right, 20 megawatts thermal.
And I'm sure we'll get to in a minute, but maybe just a quick teaser. What do they do with that research reactor?
Well, it's a neutron factory, to keep it simple and easy. It makes a lot of neutrons for the sake of making a lot of radiomedical isotopes. That's moly, that produces technetium. That's for scanning for patients with elements, diagnosing cancer, things like that. And also to produce high quality silicon ingots, like semiconductors. What happens is that we put large silicon ingots in the vicinity of the reactor neutron flux, and it transmutates the silicon to become phosphorus, making very high quality semiconductors.
Cool. All right.
And finally, and also it makes a lot of neutrons for neutron scattering experiments as well. So we've got a dedicated beam lines, and a beam hall.
Wow, that sounds like an all-purpose machine that you guys have there.
Yep.
All right, so let's talk about you. I want to hear your story, how you got into this sector. Being out in Australia, the little that I know about Australia is that you guys are anti-nuclear. So how do they find themselves some nuclear physicists out there?
Well, all right. Well, first of all, what I'm going to have to do is just walk it back a little bit and say that I'm here representing the ANA. So I do work at ANSTO as a thermohydraulic specialist, but I'm speaking here as a subject matter expert. And so doesn't necessarily reflect the point of view of ANSTO at all.
Sure.
But we got that out of the way. But to get back to what you were just saying, commenting on the perceived kind of notion that Australia is anti-nuclear, I'd say we have a couple of legislation federally and state level that are anti-nuclear, but I don't think the population is actually that anti-nuclear.
Interesting. Okay, so tell me about your personal story then.
Okay, so my personal story is that about 20 years, I was an undergraduate, and I was fortunate enough to find an internship over here. And I got very interested because I really loved how they did high-tech work. There was an experimental fluids water tunnel facility to do fluids experiment. And so I did my summer intern here. I really liked it and continued to do my undergrad thesis, and they offered me a master's of research to do a look into a little bit of flow-induced vibration of the new reactor that we have now, but which wasn't built back then. So that would be a pretty interesting piece of work for the reactor folks over in the US, I guess. And then slowly they said, okay, just get a job with us. So that's how I ended up working here.
But where did your initial interest come from?
Well, I think initially I've always been interested in mechanical engineering, like all aspects of mechanical engineering. Obviously, love kind of aeronautics, love fluids, those aspects. And I guess what attracted me to the nuclear sector was just because it's a very high-tech sector, as you know, very, very demanding kind of science required, very demanding engineering required, especially what I specialize in computational fluid dynamics. It's a very specialized field requiring, the overlaps of many different disciplines, such as numerical analysis, such as, experimental fluid mechanics, understanding aspects of that, and then also computer programming, right, of course. So yeah, that's what really attracted me to this sector, is the high-tech nature of it.
And like your peers, your classmates, what about them? How many were there? How many people were in your class?
I think approximately we had about 100 mechanical engineering students in my year. But I mean, a lot of them kind of went on to go on to find jobs in the mining industry and HVAC.
Yeah.
So those are really strong in Australia. Yeah.
And then the ANSTO, the Australian Nuclear Science and Technology Organization. What's their story? How long have they been around for?
So ANSTO has been around since 1987. It was actually created by an act of parliament. But before then, the site was actually called the Australian Atomic Energy Commission. So that was like way back, about 50 years ago when they established AAEC for the purpose of nuclear power, I believe.
And when they established it, was this part of Eisenhower's Atoms for Peace, where he spread reactors around the world?
Well, I think that was somewhat part of it. We always kind of knew that we had a lot of uranium. I think back then wasn't so sure how much uranium there was around the world. So I think we invested a lot of money into kind of gaining our own competencies so that we could contribute to the global effort, I guess, for nuclear power, peaceful use of nuclear power. And that runs in with the Eisenhower Atoms for Peace effort, I think.
And then how come when we start building our first reactor in the US and, early ones were going up around the world, how come Australia didn't jump straight into the commercial nuclear power sector?
That's a great question. In fact, it's actually quite simple. It's just purely economics. Because we have so much coal and so plentiful coal, it just doesn't make any sense to have huge amounts of nuclear power. We did invest a lot into looking at beryllium oxide, for instance. There was a beryllium oxide research section at the AAEC, and we were even looking at pebble fuels and even looking in the thorium fuel cycle initially, I think.
So there was some definite research interest. Hey, let's see where this could go. But in terms of let's put together the money to build a power plant, they're like, why bother? We have all this coal plants to build.
Yeah, so we got close to having a nuclear power plant because there was this thing called the Jervis Bay project, and we wanted to put in a steam generator heavy water reactor at Jervis Bay. But I think the McMahon government back then said, look, it's just going to cost us a little too much money, so we're just going to cut it from the budget. And so it never came to be, and now Jervis Bay has a huge car park, which was supposed to be the foundations of the reactor.
Oh, no. Was Jervis Bay, did it already have another power plant on site?
No.
Okay, so this is going to be a brand new greenfield power plant.
Yeah.
But then, what about, the clean air argument? Okay, so you have a ton of cheap coal, but surely, even in Australia, burning coal creates some smog, right? Or you guys just have, the right geographic conditions where smog isn't a problem either?
Oh, look, it definitely is a problem in those areas that have coal-fired power plants, especially lignite. So, for example, down in the Latrobe Valley in Victoria, which is one of the states in the southeast region of Australia, there are these fairly kind of polluting, brown coal plants. And recently, one of those plants shut down called Hazelwood.
Yeah.
And as a result of that, I think they took down about 2 gigawatts of capacity off the grid.
Whoa.
And so the air got cleaner, but the power bills, the cost of power also spiked as a result of that.
Yeah, that's what I've heard. We don't hear too much about Australian energy, but every now and then we get a glimpse of, oh my God, they're rolling blackouts or something. What's going on there? I thought it's a modern country.
Yeah, it's, look, it's a somewhat contentious issue because Australia is going to be going through an energy transition, like it or not, because, look, the context is that we've got 50 gigawatts of capacity in total for the whole of the country.
Is that 15 or 50? 50 or 15?
50, so 50.
Okay, wow, yeah.
And so what's happening is that, look, certain states have a lot of coal, other states don't. So, for example, South Australia, which is quite a small state in terms of population, they've transitioned to a whole lot of renewables, mainly in the form of wind, and then that's backed up by gas. So that's the firming option that they're using, open cycle gas turbines. They've also got a lot of interconnectors connecting to Victoria and using that coal-fired power to back up the South Australian grid whenever there's not enough power or there's not enough wind. And what had happened was that I think about 2 years ago, there was a blackout, and that couldn't be completely blamed on renewables having to be taken offline because the wind was blowing too hard. A lot of the power lines blew over as well, and so that was a major disruption. So,
Yeah, seriously.
yeah.
Okay, so you enter your studies. You're definitely turned on by the intellectual challenges of nuclear, as I've found that most people that I've spoken to in this industry are. It's like really an intellectual pursuit that gets them involved. And then you mentioned, hey, the people in Australia aren't that anti-nuclear. I mean, did any of your friends or family kind of give you funny looks when you started developing this niche expertise?
I think my family and friends hear too much about nuclear power to actually not like it, because yeah, but I'll just cite a few figures, right? So what's interesting is that at ANU, one of the leading universities, Australian National University down in Canberra, they did a survey about a year and a half ago looking at attitudes towards science technology. And one of the questions was actually looking at whether people supported or didn't support nuclear power. And it was pretty much dead even, right? So, and what was interesting in contrast, even though nuclear power was getting like 50% for and against, when asked whether they like gas fracking or not, actually 70% of people said they absolutely hate gas fracking.
Wow. Why do you think that is?
Well, I think that it's just, look, I'm not bagging out the gas industry or whatnot, but
Okay.
I think there's just certain perceptions in people thinking that, if I'm just trying to hydraulically fracture rock formations, etc., and it's inducing earthquakes, and I'm not sure whether it's completely controlled or not, it brings to question, brings some questions to people's minds, that's all.
Yeah.
And so the ramification of that, of course, is that, when I talk to people and they all want decarbonized energy and they love renewables, but then when I tell them, hey, did you know that most of that variable resource of energy is actually coming from maybe wind, maybe solar, but in the end, it has to be backed up by something. And inevitably, that's gas.
Yeah.
So where's that gas coming from? And, then they go, oh, okay.
Yeah. It's funny because in the US, we use that argument too a lot, at least the nuclear people do. And obviously it makes perfect sense to nuclear people, but I feel like it hasn't hit mainstream conversation, despite the nuclear industry's best attempts to levy that argument that you can't just have wind and solar on their own. They need a fossil to back them up. Most people just don't know, don't care. Are the people in Australia more energy savvy, or are you guys also struggling with that? You actually communicating that argument to a broad audience?
I think what happens inevitably is that people are rather tribal. So when they identify themselves as being wanting to decarbonize, they might automatically think about renewables. And I think what might be required is a bit of a redress, and to think of needing to consider all energy options. And when talking about decarbonized options, it should include nuclear. But yeah, at the moment, I'd say that the conversation is still going on, and there's still lots of debate and arguments.
Yeah. So, take me through to your PhD and early start to working. What became your technical area of expertise?
So, as I mentioned, I did a master's of research in flow-induced vibration for a parallel plate research reactor fuel assembly. So I was more of an experimentalist, and then I finished out the work. They liked it, and they said, "Look, just get a job with us." And then now you can start your PhD part-time doing medical analysis. So, and I thought, well, given that ANSTO is a national lab, and I understand Los Alamos and other places, they also have their own codes. I decided to do a bit of co-development myself. So that's to look into interface tracking for two-phase flow. And so that really got me into programming a lot, a lot of heavy programming. It was a risky project, but it was successful. It's a nice piece of work. But now I'm kind of shifting my attention more towards advanced reactors and understanding the whole evolution and history of how reactors have come to this point, with pressurized water reactors dominating most of the supply of nuclear energy.
Before we move on to that, and I do want to spend a lot of time talking about that, what you actually did your PhD in, so you write a code. Help our audience understand a little bit better what the fruit of your labor is at the end of that. When you have a software code for nuclear, what does it do? What is it used for?
Okay, so I mean, as we know, a lot of our reactors are pressurized water reactors, and a lot of our work requires a thorough understanding of the boiling dynamics and boiling mechanics. But to do that properly, what we need to do is have some high fidelity simulations of what's going on. So when we're looking at, say, boiling and the way that the bubbles are created, expand, etc., we have to have a very detailed tracking of the interface of the bubble in order to calculate such things as heat and mass transfer across that interface. So in the past, we didn't have that computational power. So what we did was we simplified the representation of that interface. So say, if I have a three-dimensional space and I have a cubic control volume, and I would have some kind of curved interface that cuts across that cubic control volume, then I might simplify it and just say, well, I'm just going to represent the gaseous portion as a void fraction, with just basically dispensing with the surface information and just having, say, 0.3% of that cubic control volume having a gaseous portion. And then what would happen is that the simulation would march, it's time-wise, like in terms of time steps. And then in some methods, they regenerate that interface by looking at the distribution of void fractions and trying to recreate where that surface is. Inevitably, what happens is that it's usually a poor kind of, a non kind of ideal representation when we try to recalculate what their interface is. And inevitably, that's where you have kind of errors creeping in, and slowly, your numerical solution might diverge from what is supposed to be the optimal solution. And so what I did was to have a much more thorough treatment and actually plot and track the exact position of where that interface is, and having remeshing with each time step, etc., to have a very, very high fidelity kind of tracking of that interface and representation.
And this is to be predictive of conditions that might occur, or is this to better map what's already happening in existing reactors? How would this be functionally used?
So I mean, like, if you ask any kind of reactor engineer and I was saying, well, I'm tracking one bubble in its highest fidelity possible, they'll just laugh, because like, how is that useful for me when I'm looking at some kind of transient event? So what I was really doing was more erring towards pure science, because I have a very, very high quality representation. And what I'll do is I'll use the results of that one simulation to construct a better mathematical formulation, which then therefore can be fed into 1D systems code, etc., for like, say, RELAP or TARA, etc.
And when you say RELAP, that's another nuclear code that's used to predict reactor dynamics?
Yeah, so that's right. So RELAP is a very famous one-dimensional thermohydraulics code to analyze reactor safety for transient events.
What does an individual bubble look like?
Well, I mean, it depends. Like, depending on its size, if it's very, very small, it might be circular. If it's slightly larger, say 2 millimeters, it might become ellipsoid. And the reason why it takes on certain shapes is just because of the balance of forces between the internal pressure and external pressure, and then the interplay between those two regions with the effect of the surface tension at the interface as well. So,
And this is for a pressurized water reactor?
yeah. So yeah, but of course, like the bubbles you see in pressurized water reactors are a lot smaller and behave somewhat differently from the bubbles that you and I might see on a day-to-day basis. Just because in a boiling water reactor, for instance, I think it operates about 70 atmospheres, so 70 times the atmospheric pressure of what we're experiencing currently in this room.
And okay, so this code can be used for both boiling and pressurized water reactors, but it's just to essentially model the heat transfer that forms on the outer surface of the cladding as bubbles are created.
Yeah. I
Okay.
didn't expect this was going to be so technical, an interview.
Well,
Interesting.
I'll tell you, different people get different things out of this podcast, and I try to at least go as deep as possible on one or two subjects, just so people who, I mean, most of the people listening to this aren't even in the nuclear industry, and so they just don't have any day-to-day exposure of, what's happening in a power plant and a reactor. And so
Okay.
something I try to do is try to paint an audio picture for them that both myself and my guest are compiling in real time so they can feel like they're part of the experience.
Okay. Fair enough.
And I'm also learning along the way, which is fun.
Okay, cool.
Awesome. Okay, so we can move on from that. Clearly that's done and in the past for you. You did your nerdy science thing, and now it's time to get to more practical applications.
Yeah, definitely.
When did you become involved in the Australian Nuclear Association?
Okay, so what had happened was that as I was kind of finishing off the PhD, I think actually, whilst I was doing the PhD, I got really, really interested in reactors. Seriously interested, because I mean, as I mentioned, I began just kind of looking at fluid dynamics, etc. And then, of course, when you're nerdy, you look into all these other texts as well, and you're thinking, okay, what about fusion? That's really interesting. There's lots of good work being done at the moment, but it's still like a long journey. And then I kind of got interested in some advanced reactors concepts. So, for example, I saw Kirk Sorensen's video about lifters and molten salt reactors, and I got interested in that. And then that kind of made me kind of look at all the other different types of reactors as well, like lead fast reactors, sodium fast reactors. And then eventually, of course, you circle right back to where you start from, which is pressurized water reactors. And then I asked myself, why are there so many pressurized water reactors? It's because water is such a magical material. It cools, it moderates, it shields radiation. And so from that one media, you can build your reactor system around that. And that's also the reason why there's so many of them. Also, credit where credit's due, the US invested heavily into pressurized water reactor technology, and that's the reason why there are so many pressurized water reactors around the world operating so safely.
It's so funny how you just characterized your journey of discovery like that. I felt like I went through something extremely similar. And, I don't mean to insult any of the advanced reactor companies in any way, but water, like the more that you learn and the more you try to compare things against each other and the more that you learn about water itself, the more magical you realize just plain old water actually is, which is why it's also used across industries in so many other applications. Like as I'm investigating applications of nuclear for other processes, you just realize that steam, water, is used in so many different factories, industrial settings, across the board when they need to transfer heat from point A to point B. The go-to medium is water. It's not some molten salt. It's water, 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 water.
Yeah, I mean, I'm not gonna take any kind of enthusiasm away from all the advanced concepts as well. But yeah, I mean, we should be also, as much as we should be enthusiastic about advanced reactors, we should also give a lot of credit to our existing fleet.
Yeah, so actually, let me ask you about one specific comparison between, let's say, non-water coolants like lead or molten salts and water. When I was first learning about these, I kept hearing, all the advantages in terms of heat capacity for some of the non-water coolants. But then I learned about a term called volumetric heat capacity. Do you know about volumetric heat capacity?
Yeah, great term, right?
And I realized, oh my God, water is just scoring the highest mark when it comes to volumetric heat capacity.
Sure, that's right.
Can you tell me about what is volumetric heat capacity?
Well, volumetric heat capacity is pretty simple. So say we relate everything back to water. Okay, so water's got a high heat carrying capacity. So if you look at, say, fly salt, for instance, which is one of the popular media for molten salt designs, the density, I think, is about double that of water, but its heat capacity, like its ability to carry heat per kilogram, is actually half that, about. So therefore, what happens that in the end with a molten salt reactor with fly salt, you end up with a volumetric heat capacity about the same as about the same as water. I mean, I'm just talking about unpressurized water, I think. So pound for pound, or like if you're looking at the reactor geometry, for the same amount of volume of fly salt, that would be able to carry the same amount of heat as water. However, of course, I have to caveat that by saying that you don't have to build a huge reactor pressure vessel to contain the salt, which doesn't have to be pressurized at 150 atmospheres.
I hear that argument a lot, and so maybe you and I can dig into it a little bit better, since neither of us are invested in molten salts of any sort.
Sure.
I hear that argument. Okay, so actually, water is great at carrying heat, but then we have to come up with other reasons to rationalize these other coolants, and one of them is, you don't need such a big, complicated, expensive structure to hold in pressurized water. But I don't know. When it comes to building stuff, pressure vessels for water are something industry is very comfortable and confident building. Now, we're not talking necessarily about your giant forged 1 gigawatt scale nuclear vessel, which, yes, is very unique one-off. Let's just put that aside. But we're just comparing apples to apples, things to hold pressurized water in general versus things to hold a coolant that nobody has any industrial experience with. Yeah, maybe it doesn't need to be as thick and hold as much pressure in, but we have experience with water, right? We know how corrosion affects it. We know how we can characterize it better. We know the alloy to use. So it seems to me like you're trying to justify all these advantages by moving to a lower pressure system, but you're giving up on industry experience. Does that ring true to you at all?
Look, I mean, I don't like to pitch one type of technology against the other.
But we have to. Hold on. I'm going to stop you right there. Because we have to. That's what this podcast is all about, and that's what your job is all about, is about lining all of the various options ahead of us and trying to evaluate the pros and cons. And I'm not saying we're not choosing which one's the winner. We're not giving anyone money here, but we should be talking comparatively about all their advantages and disadvantages, right?
Look, I do think there are advantages which water doesn't have over molten salt, put it that way. So for instance, Australia is part of the Gen4 Forum, and what we're going to be focusing on is looking at molten salt and very high temperature reactors. So there's reasons for that, and that's because of the high operational temperatures. So I think, the molten salt reactor experiment that was operating about 600 degrees C, for instance, which water can't at the moment. And also, it's also because of the need to kind of do across the board decarbonization. That's the reason why you need high temperature heat. So I think that's a very strong argument for doing salt. But of course, the way I see it, put it this way, the way I see it is that we need nuclear power to decarbonize. And I think that it's somewhat of a two-pronged attack. We've got kind of like in the short 10-year time frame, looking at advanced reactors, advanced water-based reactors such as small modular reactors, for example, the NuScale that's coming soon, and then some 15, 20 years down the track, maybe high-temperature gas reactors, molten salt reactors are also coming to the fore. So I think it's good to have a good kind of spread of technologies, especially if you can eventually reduce the price per megawatt hour.
Right, but that's what it all comes down to, right? Because at the end of the day, you can always get steam hotter by just applying some electricity to it, right? So if you have your light water reactor and you're going to take an efficiency hit by applying some of the power output to reheat steam or to superheat steam, you have to work that into your economic model just like you would have to work into your economic model any cost disadvantages working with a new a first-of-a-kind system or new alloys or materials that you might have to use for when your heat source is hotter to begin with. But so it's like what I'm trying to do is just lay out a fair economic comparison between the two. If what we're saying is, hey, we want low carbon, hotter coolant of some sort, you can get there many different paths. One is by using a molten salt system, one is by using a lead system, one is by using a normal light water nuclear system and then using some of that electricity to get some of the steam hotter again, which might actually even be better for industry anyway if they're used to those pipes or it's easier to hook up. So we have to do a fair comparison across the board. And then I think what we can do out of that is say, okay, well, what price do you have to beat light water reactors on, molten salts to get you that hot temperature, to get that higher temperature out of it? Because then you can say, okay, molten salts, you're not just allowed a free pass, saying you can deliver at $7,000 a kilowatt or something. You've actually got to come in at, $4,000 a kilowatt in order to be cost competitive against superheated light water reactors or whatever, right? Is that a fair way of looking at it?
Well, to quote, I think Donald Rumsfeld, is that we don't know what we don't know. And to know what we have to know requires investment.
Yeah.
And so I think, for example, the Chinese government is investing a lot of money into molten salt reactors. So you might know that the molten salt reactor program, I think it's like $3.3 billion to constructing first of a kind over in Inner Mongolia. But having said that, they're not, their main game is actually rolling out lots and lots of pressurized water reactors. And when I am asked, how should we do decarbonization properly? I say, well, if you look at some centrally planned economies such as China, it's quite staggering. They've managed to double their nuclear capacity from 27 to 54 gigawatts in the space of 5 years. That's incredible, right?
Amazing.
And so by 2030, the low end estimate is that they're going to have 130 gigawatts of capacity.
Whoa.
Possibly with about 500 to 540 gigawatts of capacity by 2050. So we're talking about more nuclear power than what's existingly currently in the entire world of about 400 gigawatts, right?
Yeah.
And these figures really give people pause and think, right? And so, in fact, these figures actually come from the Energy Research Institute in China, which I think is responsible for the central planning of all energy generation in the future. And in fact, I'll give our ANA conference a little plug here, is that we're inviting the head of that institute, Dr. Keijun Zhang, to give a talk about that to our industry people here. Let them have a little think about it.
Yeah, no, I keep trying to warn people as much as I can that unless we get our act together, we're all going to be buying nuclear power from China, just like we buy our solar panels from China right now.
Yeah, it's interesting. Hey, when currently there's a lot of coal-fired power plants in China and they're converting that power into making solar panels, which we import.
Crazy.
So in some ways, we're importing coal-fired power.
I know. Hey, you just mentioned they've got a lot of coal-fired power, and you mentioned they're building a lot of nuclear powers. Have they nuclear plants? Have they ever considered just swapping out the hot rock, replacing the boiler in a coal plant with their nuclear reactor, and that way they can deploy even faster?
Yeah. So I'm not sure about a direct swap out of the boiler. The coal-fired power unit with high temperature gas reactor itself, but I think that they are actually swapping. They're doing the same kind of steam generators, put it that way, because they're looking at having commonality, and I think just basically minimizing having different designs, etc. So that brings to mind, I think the Chinese are commissioning the first of a kind HTGR, like commercial basis, called the HTRPM.
Cool. What are the characteristics of it? What should we know?
So I think the highest operating temperature is about 750 degrees C, and currently they're commissioning a plant with two RPVs, reactor pressure vessels, feeding one steam generator. And the output power is basically 200 megawatts, so 100 megawatts each from each RPV. I think the next iterations, basically, they're going to have 6 RPVs feeding one turbine to give an output of 600 megawatts. And all these reactors are going to be, I think, they're going to be commissioned inland because they can be air cooled. And all the PWRs are always all going to be on the sea, by the sea where there's lots of cooling water.
So, do you know what the fuel form is for?
Yeah, so it's trisol fuel, I believe.
And it's going to be in like pebble form or some sort?
Yeah, that's right. In pebble fuel, so I think similar to what the Americans have, 6 centimeter diameter fuel.
And so you in Australia, you're a lot closer to China. I bet you guys are big trading partners also, right?
Yeah, that's right.
So you probably have a lot more insight as to what's going on in that whole region of the world. Do you think that China's going to start trying to sell Australia nuclear reactors at some point?
I don't know. I haven't heard anything about that, but I think some of our ANA colleagues, when they ran into a few Chinese delegates over at ICAP, were invited to go and have a look at the reactors.
And you'd welcome it, right? Because it's like, like in the US, we're like pretty competitive. Like we want to sell our reactors, not China. But like you there, since you guys don't have a national vendor of any sort, you'd take Chinese nuclear if you could get it, right?
Oh, I don't know about that. I don't know if we're going to take any vendors at the moment since we've got the ban currently.
But okay, so let's talk about the ban then. You brought it up. Let's talk about it. What are you going to do to get rid of that ban? If we want nuclear out there, we gotta get rid of that national ban.
Well, I think this interview is somewhat timely because there's currently 2 inquiries underway.
Yeah.
One on the federal level in the Senate, looking at the possibility of using nuclear power in the future. But the current position of the government is that there will be no change in the law banning nuclear power federally. But at least they're looking into some of the potential benefits of having nuclear power. That's the exact wording. And then on the state level, there's an inquiry actually looking into removing the ban on nuclear power in the state of New South Wales.
Oh,
so that's currently happening.
So how does that work? Because I don't understand your system. You have your states can act independently of the federal government?
No, it can't. But so just to walk it back a little bit, for the listeners out there, there's actually 2 major pieces of federal legislation banning nuclear power. One is the EPBC Act, the Environmental Protection and Biodiversity Conservation Act. In Section 140A, it's expressed that no nuclear power plant is allowed to be constructed. With any kind of large piece of infrastructure, it requires environmental impact assessments and that kind of stuff, right? So that's one act. And then the other act is the ALPANS Act, which forbids, I think, the federal nuclear regulator from licensing the operation of a nuclear power plant.
And did they give any reasons why, when they created these laws, did they say it's because we think it poses an environmental risk, a safety risk? Like, did they say why?
I can't confirm for sure, but I believe that about 20 years ago, the act was changed as a way of appeasement for the Green Party, because we wanted to have a replacement research reactor, and the Greens vehemently kind of opposed it. And the government kind of said, look, can we compromise, and we'll put the ban in for nuclear power to allow us to at least have a small research reactor to make medical isotopes. So.
Seems like a bad deal. It seems like losing that kind of ground I mean, that's a pretty big sacrifice. You know, I get that you
Yeah.
want a little bit of, you know, reactor here and there, but to give up all commercial future nuclear power, it seems like it's once you go that direction, as we're finding out right now, it's just so hard to undo it.
Yeah, look, I think the federal government, I think the Howard government at one point was considering lifting the ban on nuclear power because about 10 years ago there was an inquiry called the UMPNR, and out came the UMPNR report, which advised Australia having lots of nuclear power plants. There was talk about possibly even constructing 10 AP1000s, for instance.
Awesome.
But the Howard government wasn't re-elected, and so that was completely shelved and forgotten about.
Does it fall along, I don't know who Howard is, does it fall along party lines when it comes to pro-nuclear versus anti-nuclear? Or when I say party lines, I mean like what even kind of parties might like it or not like it?
Well, I mean, I'm gonna, as an ANA representative, I'm gonna stay away from the politics of all this. Plenty of people talking about the politics, but I mean, I'll just say that inevitably, the whole issue gets a bit politicized, and that's unfortunate because, I just want people to see nuclear for what it does, which is it produces huge amounts of very low carbon electricity. I think the simple comparison is just looking at France and Germany, right? Looking at the carbon intensity is like 50 grams per kilowatt hour in France, compared to maybe like 350 in Germany, even though they've invested so much money in renewables.
And nobody goes after these Greens and says, like, you say that you're for the planet Earth, but you go after nuclear before you go after coal. What sense does that make? I mean, everyone knows, like, it's not like coal's hazard to the environment and human health is a mystery. We've known about it since the beginning of time. Black lung and people who live in cities near the smokestacks get sicker more often. It's like, how have the Greens not... How is that not, like, apparent to them that coal is the bigger problem? Why even invest your time going after nuclear before all coal plants are shut down, period, end of story? Like, what's going on in their heads?
Look, I mean, I think a lot of people who dislike nuclear, they somewhat confuse themselves into thinking that nuclear power is about nuclear weapons, which it's not.
Yeah.
There are so many countries that produce a lot of nuclear power, doesn't have nuclear weapons at all. And so the fear of nuclear weapons is actually, I think, what drives a lot of anti-nuclear power feelings.
And then it's almost beholden upon us in the nuclear industry to make sure that they know that if they're not related, that nuclear power and nuclear weapons are not related. Do you guys have any, at the ANA, the Australian Nuclear Association, do you guys have any like public outreach division or strategy or anything like that to make sure people know that?
Well, I mean, the ANA is a collection of professionals from the nuclear industry, nuclear scientists, nuclear engineers. And so we do give talks over Engineers Australia and other places to talk about the technology. It could be pitched a little bit high for the normal general audience, but we're trying our utmost to reach the audience with kind of more plain speak presentations. The point of the matter is that there's to really reach out to a much wider audience requires a lot of resources. So we have a place in a lot of different groups that are talking about nuclear, but we tend to stick with the technical and the facts more, and maybe less trying to steer this conversation less from the politicized nature of the whole subject.
So who would be the organization to commit the resources within Australia that could really get it turned around, that could educate the public on what nuclear is, that could advocate for nuclear? What organization in Australia would do that?
Well, the Minerals Council of Australia has come out very strongly in support of nuclear, and I think they are the type of organisation with the resources to be able to do that, and they have been doing that.
Minerals organization. What is a minerals Association?
Minerals Council of Australia, yeah. So it's a very large body that represents many different mining companies and industries. So they understand, I think, the narrative between having huge amounts of power, industrialized levels of power, and the way that converts minerals into value-added resources that can be exported overseas.
But does that include the coal plants as well?
It does, actually. I think.
Ay, ay, ay. If our greatest advocate is going to be in the same council as the coal and the gas people, I'm not too excited about the future there.
Well, maybe you should try and tee up an interview and see what they say.
I know, I definitely will. If you could put me in touch with them, I'll get right into it with them for sure. What so you spend your time doing what mostly now? Looking at the Gen 4 stuff?
Well, I mean, my day-to-day job is to look after the safety of the local research reactor. I'm part of like one person from a huge team of people. So that's my kind of bread and butter. I like to be doing more research into advanced reactors, and so I lived my life precariously through a few PhD students.
Okay.
So one of them is doing solid fuel liquid salt design, similar to the one that Per Peterson's looking at over at UC Berkeley. He was seconded over there for 6 months.
Yeah.
And another one is looking at recoding Monte Carlo M particle code for accelerated calculations for neutronics. And I think he was seconded over at U Florida and also was at Argonne National Lab. So there's a little bit of a link between ANSTO and the US, so that's good. And then thirdly is I keep an eye on the nuclear reactor technologies overseas and see what's happening because it's part of ANSTO's responsibility to understand what's going on. Obviously, we export a lot of uranium, and so the government would like to understand what's happening and understand the context of what's going on.
Yeah, cool. So as we wrap up here, maybe you can just kind of paint the picture of what you think the future looks like 10 years from now. Where do you think the industry is going to be?
Well, I mean, fingers crossed. I hope that eventually we'd be able to lift the ban on nuclear power. And I hope that we get a few kind of units going in Australia. Of course, I'm not going to say which design. That has to follow a process. I'm not going to say which site. That has to go through a process. Community outreach has to be with agreement with the community. But yeah, I think Australia's situation is good. I think the conversation is good at the moment, and things will pick up with regards to the nuclear industry.
Marco, thank you very much.
Thanks very much.
See you later.